Good evening, everyone. We'll start with today's session. So, our topic for the day is roles and responsibilities of piping engineer. So, this will be the last training session of this entire training program. Our trainer for the day is Mr. Chandramohan. So, I request Chandramohan sir to take forward the training.
Thank you, Anu. Hope my voice is loud and clear. Okay.
Yes, sir.
Okay. Good evening to all. Welcome to today's session, training session. Today our training topic is roles and responsibilities of a piping engineer. So, sorry for yesterday. I held up in one meeting, so couldn't able to make it yesterday. So today we are continuing that one. Okay. What is the importance of piping? So in not only modern society, piping system is like our arteries and veins in our body. Like arteries and veins, the piping system is important for any industries or any firm. So piping is the safest way of transporting of substances. That means any fluid. Piping is amounting as around 25 to 35% of the capital cost of a processing plant. Apart from the land cost, equipment, and then process design, this piping alone piping and its components alone 25 to 35% cost of the total budget for any industries. So why we are mentioning here means we should be very careful, and we should be very we have to design properly before proceeding any plant constructions. 1 second. This is a piping arrangement for the sample I'm showing here. These are photos of an finery plant we are showing. Here you can see a lot of piping going here and there. So mostly these lines are insulator lines. Most of you may got an opportunity to see pipelines in plant training, or most of you may be working with some other companies, may get this opportunity to see the pipings. So here this insulator lines, white color lines is there. I said insulated lines. These are all insulated lines. Mean hard services and all will be insulated. Mostly this green color showing these and all will be cooling water lines. And then here this orange color, mostly it will be a nitrogen kind of lines. So this is a piping arrangement. While I'm saying it's a nerves in our, like nerves for any industry, piping is like a nerves, which is important to transfer a liquid from one place to other place. This is a sample piping system. Here you can see. So just I wanted to show some model. That's why I'm showing here. It's a suction valve, discharge valve, pressure gauge, everything this one. And then it's going to the discharge line. So we are going to see in roles and responsibilities only. So before that, I wanted to just cover. Okay, pipelines and pipelines have been used from ancient days to transport resources from one location to another. It is the fluid may be in any form, liquid, gas, or vapor, or both mixed, or any suspended solids. The piping system used to transfer from one place to other place. Some sample domestically in cities and households, piping serves to supply water, sanitization, waste disposal, cooking gas, that means NG, and firefighting. We are used domestically. In chemical plants, paper mills, food processing plants, and other similar industries, this piping and all used as a one way of transferring a liquid, a fluid from one place to other. Like in cement plants and PVC plants, it will use it to transfer the cement by pneumatic conveying. Hope you all know about pneumatic conveying. To transfer the solid or substances from one place to other place, we will use this kind of pneumatic conveying system. You have seen some many tall buildings or construction is going now. So that end area, they will use this kind of conveying system to move the solid metal like brick, cement, everything to take to the top. So some pipelines in refineries, crude oil from oil wells to tank farms, or from storage tank to refinery units, or from any tanks to refineries bottling units. So these are pipe plants are used in these kind of areas. And then natural gas transportation and distributions, like convey natural gas from one source to other source, from storage tank to some other day tanks, or from day tanks to tanker, like that we are using pipelines. Here, piping engineering. Piping engineering is one of the most important groups in oil and gas, where in all industries like petrochemical, refinery, chemical, steel plant, pharma sectors, everywhere. The prime responsibility is of engineering, design, analyze, field execution, commissioning, troubleshooting if any issue is there, and all other aspects of piping system. So not only these are all not only piping engineer, there will be a design, analyze, it will be under piping engineer, field execution, commissioning will be under commissioning engineer, troubleshooting also under commissioning engineer. So there will be two sector, commissioning engineer and a piping engineer. So mostly we have to be know about these commissioning jobs also. So then only you can rectify, then only you can pre-plan. So what we have to do in designing. Piping engineer, what has to deal with? He has to deal with high temperature, hazardous condition, like that fluid may be a high temperature, high pressure, flammable substance, or vacuum, or corrosive substance, toxic, radioactive, cryogenic, in any other form. The piping engineer has to deal with the fluids. Accordingly, he has to deal with, design the piping. This is the major role and responsibilities of a piping engineer. Preparation of a plant setup and layout according to the plot plan, available area, and then preparation of the equipment. Already we have seen about plot plan in our earlier training sessions. Second one is preparation of equipment layout based on the PNDD and PFD. He has to choose which equipment should come here based on the PND, and discuss with the other discipline members like process engineers. He has to prepare the equipment layout, and then piping layout and placement, piping material specification. Hope you all know about PMS. It is very important for any project at the initial stage, because this is only going to decide the whole project. If you make any mistake here, it will make the huge cost, or it may leads to a big accident. So PMS is the main thing before proceeding for any project, particularly for piping engineers. And then piping supports and its specification preparation, perform piping stress analysis, CAD or 3D modeling he has to perform, and then from 3D model he has to extract the 2D drawings for, isometric drawings for the fabrication of pipelines. These are all the major roles and responsibility of a piping engineer. Piping engineering category. This piping category, there are four major categories: plant and piping design, piping material engineering, and then pipe stress analysis, and then piping constructions. This construction all comes under field engineer execution, who is going to execution. Stress analysis is a part of a piping engineer. This plant and piping design and piping material engineering will be the main scope for any piping engineer. So plant and first we have seen a plant and piping design. One by one we are going to see in detail. Plant and piping design. Plant layout designers optimize facility or an unit to optimize production process for safe, efficient, and effective flow of work. And he has to take care of cost, time, safety, environmental friendly, and aesthetics. Piping design engineer who designs the layout of a plant, location of any equipment. Earlier said, he has to decide the location of the any equipment according to the PNID and PFD. Which process has to comes next? Like we in upcoming slides we will go to see in detail. And then piping routing, location of supporting structure and underground facilities. These are all piping design has to take care. And then piping material engineering, creating the project piping classes. As I said earlier, in your pipe in your industry, what we are going to build, It may have various numbers of fluid you are going to take care. In that, for steam will be there, corrosive liquid will be there, oil will be there, water, condensate, cooling water. So those kind of fluids, first initially we have to prepare the PMS. So which valve we have to use for at what pressure, for how many pressure range we have to use the what kind of valves. So in which service we have to use the insulation up to what temperature, for which pipelines we have to use the painting code. Those and all comes under the piping material specification. So this only decides the cost of the project, I mean cost of the piping factor in a project, also the safety, and then your early completion. A piping stress analysis engineer, a person, I think already you have attended the training on piping stress analysis. It's a part of a piping engineer, not a main one. So some other person will be there, he will take care of the piping stress analysis. It's a part of the project, but piping engineer should know about the pipe stress analysis, what they are doing, or what will be the outcome, like that. He has to ensure the piping routing done by the piping designer and consider the allowable applicable piping codes. He has to evaluate the piping flexibility and stress analysis, measure the effects of support settlement, safety relief valves, seismic loads, thermal. Already we have seen thermal cyclic loads and wind loads, etc. He has to take care of, and which support has to be suitable for which pipelines, at what size this kind of support we have to use. If low bore pipelines means what kind of support, if big bore means what kind of support, if it is high temperature, if any thermal expansion loop is required or not, what kind of support is required, guide support or fixed support or shoe support or some spring support, whatever it is required, it has to identify through this piping stress analysis for the critical pipelines. Piping construction and commissioning engineer, their roles and responsibility is to execute the piping as per the drawing, as per in the PNAD, as per in the piping layout with the isometric. He has to install the piping and he has to supervise until commissioning has to get over, including testing, everything he has to take care until commissioning the plant. He has to be, he is the responsible one. Is the owner, designer is responsible to the owner for assurance the engineering design is piping complies with the requirements of this code with any additional requirements established by the owner. This one is, if it is a standard plant, if it is like a power plant, if it's a refinery, there will be a set of codes is available, like 31.3 we have, 30B 31.1 we have. So those kind of codes and standards will be available to execute our design. There will be some guidelines will be there, and also here with any additional requirements established by the owner. Why this point is, some other specialty chemicals will be there, some in pharma industries or some other chemical industries and all. We cannot follow the standard piping design because their fluid will be different from the standard petrochemical or power plant, like steam. If you say steam, it will be steam everywhere, will be same only. So those kind of codes and standards are applicable for steam in anywhere, power plant or refinery, everywhere. Same like crude oil also, it is same everywhere, all throughout the world. But some specialty chemicals we have to take and care according to the owner requirement. So because a piping engineer may not know all the chemicals, how it will behave, everything. So that he has to discuss with the owner and he has to follow the code for that. The designer is responsible to the owner for the compliance with the requirements of all codes to be followed. In some cases, the designer is responsible to identify the relevant governing codes as required. We have to suggest and we have to plan that one. Owner is the plant operator. A designer is the engineering service provider, like what code says? The code specifies engineering requirements regarding safe design, construction, operation, and maintenance of pressure piping. The code is not a design handbook. Many decisions that must be made to produce a safe piping installation to maintain the integrity within this code. There will be a guidelines only that fully we cannot go as per the design. Based on the safety aspects, based on the specialty chemicals, you have to follow those kind of codes. Piping design, the basic concept of piping design is safely and economically transport a fluids from one place to other place without a considerable pressure loss. The piping associated with the plant or facility can be divided into two categories, as you all know, I think already. ISBL, OSBL. ISBL means inside boundary limit, OSBL means outside boundary limit. Whatever the processing unit, that will be a boundary unit, we call as a boundary limit. What will be the raw material storage or final storage, or wherever we're getting the chemicals from the other industries for the as through pipelines, those and the utilities, those and all comes under the OSBL, outside boundary limit. The steps in the piping designing is the characteristics of the fluid to be carried out: flow rate, allowable head loss, vapor pressure, terminal pressure, level difference. These are all you have to be considered, and then design code to be followed, and the material MOC to be followed. The determination of the preliminary pipe route based on the plot plan, based on the our PNID. So the piping route and the line length, static height different. These are all you have to be considered before designing any piping. And then pipe diameter based on the allowable head loss. That and all comes under the pipeline in-depth design engineering. Already we have seen stress, flexibility analysis, code compliance, support design, that is anchor support, or as per the analysis you have to choose the support. And then preparation of drawings, specification, and a design report. These are all the preliminary steps in the piping design engineering. A plant layout, already we have seen this one. Plant layout is, it is a design of process plant in any complex within the plot plan. We have to design the how process, how will be the mechanical piping, electrical routing, instrumentation routing, that is electrical cable trays, instrument cable trays, earthing layout. So those are and all comes under the plant layout. So that and all you have to be considered while constructing any piping layout. The objective is to design and construct a plant in a cost effective manner. So our major role is to construct a plant in a cost effective manner by minimize the design, engineering and construction schedules and getting the plant on stream as quickly as possible. That is, you have to design the plant in a standard way to make it a construction within a short term. So every owner will see as a payback period. So how much we are investing and within how many years we are going to get back the investment amount through the plant. So your construction should not take too long. Of course, it depends upon the construction party who's built. Same time, it is the piping engineer role also to make the plant in a compact. So wherever the possible symmetrical design we have to follow, similar kind of set of design you have to follow, so that the fabrication will be easy and the installation will be easy. And then minimizing, second one is very important, minimizing and eliminating the field rework. This only cost us the more job, because in our earlier project, as per the any work, any project we are going to proceed, there will be already explained, there will be a pump pipe inch dia will be there. That means how many inch dia we are going to build. So based on the P&AD, based on the isometrics, like iFluids detail engineering consultant will give the approximate, not approximate, 90 to 95% of the inch dia they will give. So based on that inch dia, that owner will create some schedule. But if any rework is there, the schedule may getting increased. So same like time and cost will get increased. So based on that, we have to decide the piping. That means in isometry, we have to mention that which one is field weight, which one is the shop weight, that and all we have to mention in the drawing. And then constructability, maintainability, that is I already explained in the I think in earlier schedules. If maintainability is nothing but if pump you are making or any heat exchanger you are erection is there, so the pump equipment to equipment gap you have to be maintained as per the code. Because if you to maintain the plot plan very close, you cannot put the pump very close, because while other pump is running, other pump, that maintenance in future they have to do the maintenance. So that maintenance activity should not create any problem on the running equipment. Same vice versa. This is a maintainability. If any exchange you are designing, if any bundle, you have to in future 3 years or 4 years, you have to any problem or for testing purpose or cleaning purpose, you have to remove the bundle. So I don't know. I want to design the compact. So if you put any pipeline close to the in front of the exchanger, in future you cannot pull out the bundle. So those kind of the things you have to keep in mind. So what are all the equipment is there? If in future if this equipment any failure, how crane will approach here? If this equipment any fire hazard is there, how the fire tender will approach, how the hydrant will approach. So those kind of the things you have to keep in mind while designing the piping layout as well as the piping. Operability, that is already explained. Pump equipment to equipment, the distance we have to maintain. Satisfying the environmental condition that professional ethics we have to maintain. There are the two types of project facilities. Majorly we divide in industries. First one is greenfield project. Second one is a brownfield project. As the name itself implies, greenfield means we have to start from the scratch. Like there will be a fresh land will be there. There we have to start from piling to a production. Brownfield is on the other hand, already plant will be there. There that the plant operating plant adjacent to that or nearby, they are going to build another plant like an extension, like other kind of project. They will go for a extension project. Those kind of project is called a brownfield project. So we are going to see in detail. Brownfield project is projects executed wherein the existing facility or existing one plant will be running. Adjacent to that, we are going to put another one plant that is called brownfield. The site is already developed with the required infrastructure. That means road and then getting approval from government, statutory requirements, manpower and resources, utilities, powers, water, those kind of things already will be available. That is called infrastructure available nearby the brownfield. From that point, we need to develop a new extension one. The projects of new expansion, revamp projects, yield improvement, etc. comes under the brownfield project. Revamp means if any new expansion means they are expanding the capacity of the plant. Existing capacity 5 ton production, they again go increase the plant production to 10 ton per day. That is called new expansion. Revamp means they will not, the efficiency may not good, or there will be some defects will be there, repair work is there. They will remove the existing equipment, they will install the new equipment. Those kind of revamp projects. And then yield improvement, like productivity will not be there for the input, the required output may not come, so we have to improve the yield, so we have to do some modification. Those and all comes under the brownfield. This is a greenfield project. The picture is showing this is a greenfield projects. What are the advantages? Like I said, greenfield project means not only green, we have to start from the scratch. Nearby any plant will not be there. From the fresh land, you have to do the topographical survey, do the studies under the environmental studies, how the wind load will be there, seismic load will be there, how the soil condition will be there. Because whereas in piping, brownfield, already one industry is there. So we can get not only utilities from that plant, resources from that plant, also we can get this kind of information. Because initially that project, initial project, that existing plant, they made soil investigation. Those soil test report we can use for this project. So our cost will get reduced. And then statutory requirements, they already got approval for that plant means it is also for the easy for the new plant approval also. And then wind load, seismic load, those kind of things they already considered in the existing plant. So it will be easy for us to get those documents. We no need to worry much. Whereas in greenfield project, you have to take those kind of things. Okay, in greenfield projects, what are all the advantages? No, more expansion is possible because we have a lot of land. We can design accordingly and completely new. So no need of demolition. Your interconnection is unstable. Okay. What are the disadvantages? Accommodation could be difficult because it is far away from the managed area. So there will be accommodation. People cannot stay there because there will not be any resources or utilities, powers are not available. So it must be built beforehand. Limited local suppliers in undeveloped location. If this is a remote area, there will not be much resource for us to get any items. I mean, for the plant construction purpose. There could be a governmental restrictions if deforestation or similar environmental issue arises. Because for putting any new plant, we have to do deforestation. It may require. So for that, we have to get approval from the government local bodies. It may take a lot of time. Whereas in the brownfield projects, advantage is codes and standards are already available. That means existing plant, what are the code stands, PMS they have followed, philosophy what they have followed, we can take that one. And the utilities readily available at site like water, power, vehicles, everything will be available. If you need any crane, existing plant it will be available. You can use that one. Whereas in greenfield project, you have to rent a crane or you have to buy a crane separately. So those kind of things as a vehicles. Infrastructure is well established. That means you need more manpower, already manpower here available, whatever the resources, like you can imagine you are building a new home at the fresh land and you are building your new home near to your parents or home. So what will be the difficult? So you can assume. Disadvantage is fire hazard risk is very high. That is one disadvantage because nearby, if it is a petrochemical plant or refinery plant, you have to barricade this area where whatever the plant extension is going to come. There will be a large, more probability for fire hazards. So that things you have to be very careful. Limited space, difficult in further future development. Even finding the required plot size could be difficult because we have, if a brownfield project, there will be a limited space only available. There we have to accommodate the all equipments. So those kind of things will be difficult in brownfield project. Data used in plant design means what are the plant data is required means project data, design and engineering data, vendor data. These are the three major data required to do a design for any plant. Project data is nothing but information such as plant location, soil condition, that if soil condition is good or not, we don't know, we have to do soil investigation, and then extent of facility, local codes and regulation, logistics, access to the roads, because nearby any main road is there, we have to connect to that road. So for that we have to make a road, waterways nearby any harbor is there or not, railways is there or not, wind load, seismic condition. These are all the data required for the plant design. That is called, this all comes under the project data. And then design and engineering data is internally generated during the design and engineering phase of the project. Example, that according to the service, that equipment sizes, service condition, pressure of the fluid, temperature of the fluid, corrosive nature of the fluid, mass flow rate, these are all the required data for design and engineering purpose. Vendor data is, that is ready-made equipments like pumps, compressor, boilers, cooling towers, columns. These are under any machineries we have to get from the third party, that means vendor, as per our requirement only. But those kind of such data should be available with us to proceed with the plant and to design the plant. What are the skills required for a piping designer, piping engineer? He or she should have analytical skills, project management skills, written and verbal communication skills, observations, and drafting skills. And then common sense and attention to details, ability to think creatively, to solve layout problems and challenges, because some area we may have constraint, space constraint will be there. There, how do we have to lay the pipelines? So those kind of the things we have to face while designing any piping layout or piping. Ability to think and visualize spatial relationship between plant items in 3 dimensions. Effectively use computer aided tools like 3D modeling, we already seen, and then stress analysis software, and then able to coordinate with the other disciplines and should know about basic things in the other disciplines. Then only we can do the plant, piping or equipment layout. Because for any instrument, how the thermocouple will be, how the motor will be running, so where they will take the power cable, So for that switch box where we have to provide the support, so those kind where they will provide the support. So those kind of the things you have to keep in mind. So while designing any pipe equipment layout, not only in the mechanical thing as well as the instrument. If any piping you are taking out there, so above this one instrument rack will be there. Above that one electrical rack will be there. So those kind of the things you have to keep in mind when designing a pipe rack. Not only we see about the mechanical piping, also the other disciplines. Because if a mechanical, there will be one major problem is there. As a mechanical engineer, I faced many issues because if you take instrument engineer, they will do their part only, instrumentation only. If electrical engineer, they will take care of only electrical only. They will not think about the other discipline. But as a mechanical engineer, next to process, we are the major, we are holding the major responsible, because we have to take care of the not only our mechanical pipings, we also have to take care of the structural things. Okay, and we have to take care of the safety things, because safety is there will not be any separate person for safety equipments or safety related items executions. We are the one who is going to do the piping or piping design, piping layout for the fire water pipelines also. So those kind of the things are additional job for us. And then for the cable rack or the instrument rack, they will not prepare the support on their own. We have to provide the support for instrument and electrical. So our job is double the time of the other discipline job. So mechanical are the 60%. If it comes to execution, commissioning, 60 to 70% jobs in our hand only. And then our ability is to function effectively as a member of any multidisciplinary project teams. Effectively communicate and resolve layout issues and problems with project management. We have, if you see any project manager, if any project they are going to put, they will choose a different discipline. Safety one person, process there will be one person, like mechanical, civil, instrument, electrical. Who, if you see who will be the lead while designing, up to designing only, up to preparing the P&AD, only process person will be the lead in the project team. After once the P&AD is freezed, once everything is process everything freezed means, who is in the mechanical person, he is only going to lead the project team. Whoever has experience, he has a less experience also, the management will ask the mechanical person only to lead the whole project until the completion, because he only has to deal with the civil, he has to deal with the other discipline, including safety. So our roles and the responsibility is much in designing as well as in the commissioning. And the knowledge of operating and maintenance procedures used for equipments, not only piping. So how the compressor will be working, how the boiler is working, how the cooling tower is going to work, why they using cooling tower here, why not some other thing for exchangers only, why they are going for cooling towers. So those kind of the things you have to think, how they it is operating, how they will in future they will do the maintenance, those kind of things you keep in mind. And then excellent communication skill as well as, and then sufficient knowledge of process being used, including function of each equipment. So that means a process person may mention here slope is required. So for that you have to be very clear why slope is required. So what kind of chemical they are using. So that's why we need slope here. So accordingly we have to design the piping. And then basic understanding of the process. What they are going to produce, what is the raw material, what will be the major process, what is the outcome of the plant, product. So those kind of the things you have to basically, not in depth. That means heat, heat and mass flow rate, that and all you don't need to in depth you have to see. But you should know that what is from the feed, what is coming. For each equipment outlet, how it is changing, the property is changing from liquid to vapor or vapor to liquid, why it is changing, those kind of the major things you have to know. And then do not just follow the P&AD and the equipment GA drawings blindly. Why I mention here means, because in P&AD also there will be some mistake. In equipment GA drawings also there will be some mistake, because equipment GA drawing will be prepared by the vendor and the P&AD will be prepared by our project team. Okay, in P&AD they may mention this pipeline has to connect in the nozzle 1. In GA, that communication may not properly communicated with the vendor. So they may choose the N1 as a N2 nozzle 2. So before doing piping or before doing any commissioning, so from our side we have to see Okay, it is reasonably it is connecting or not, why it is connecting. So those kind of the things you have to keep in mind. There is no thumb rule for piping design or piping execution, but set of some rules is there. The approach to the plant layout and piping design can vary depending upon the nature of the plant and the project. For example, the design philosophy of for an offshore facilities completely differs from the onshore chemical plant because of the limited space available on the offshore platforms. So those kind of, according to the process requirement, according to the where the plant is located, our mindset should be accordingly we have to prepare our mindset, because as you know, everybody know what is onshore, what is offshore. Offshore is like an oil well platform that is located in the sea, not mid of the sea, in sea, where the it is island. If it is located, this those kind of things comes under the offshore. Like our power plant, chemical processing units, those in the land, right? Those will comes under the onshore. There will be a lot of completely there will be different in all system, flaring, piping, and then safety systems. There will be a lot of different is there. However, there is a few useful rules of thumbs are available while designing the piping layout or piping design. So knowledge and understanding of project requirements and project documents, a consideration of space and resources, arrangement of equipment in a neat, organized manner, taking into account process needs and safety. Why is the neat and organized manner means the plant not only piping design, our that look also should be very neat. A plant while seeing anybody seeing should be neat and organized manner, because in some other plant we may have train 1, train 2, like that. The same process what is happening here, the same only the process only happening will be the train 2. So identical, we have to design the plant in an identical way, so that it will be easy for the piping execution, checking the drawing and commissioning, testing, even for operation also it will be easier for the future operating persons also. So those kind of the things you have to keep in mind. And then attention to detail, including adjacent equipment, support and other items, which can cause potential clashes between piping and equipment supports. So those things means, okay, if it is a flammable hydrocarbon lines you are laying in a pipe rack, means that fire water hydrant line should be away from the flammable lines. Whether if it is not possible to take it the underground, so it may require to take the other pipe rack, same pipe rack also. So you have to put flammable pipelines at this corner, and the fire hydrant line should be on the other corner, because if any fire is happening, the fire hydrant line should not get affected, so that we can extinguish the fire. So those kind of the things you have to keep in mind. There will be that is why there is no rule of thumb in pipe rack. Designing the pipe rack based on our owner requirement, based on our design, based on the plant only, we have to decide. So obviously the cable rack, whatever the electrical instrument cable rack is there, cable is there, it should go above the pipeline. Why it should not go below the pipelines? So those kind of the things you have to keep in mind. And then if you are taking a cooling water lines, cold, hot temperature, cold temperature line means you have to separate it. If it is steam line, you have to put it in the same rack. If it is a cooling water service, utility service, you have to put in the another rack. Tire 1, tire 2. If it is one tire is there, that one side corner there will be a hot service, another one is a cold service. Those kind of things you have to keep in mind while designing the piping layout. Pipe rack and piping layout. Same thing while inside the plant also, not only in the pipe rack, inside the plant also, the cooling water line should not touch with the hot service line, because it may take the temperature from that. There is no meaning of using cooling water. And then consideration of constructability, operability and maintainability of the plant. We already discussed this one. Routing of a pipe in neat, orderly and symmetrical manner. That manner keeping in mind and the future needs of the plant. That also we have to keep in mind, because wherever we are taking any steam, utility lines, we have to keep one tapping point for the future purpose with the isolation valve with the blind arrangement. So we may don't know in future what the owner is going to extend the plant or not. He may going to set up a new plant. So that time again piping, routing and all not required. We can take from this valve tapping. So based on that we have to design. Even though the owner may not know, but we have to suggest better you keep here one a tapping point. In future it may require for safety purpose also. This pump you have to diesel engine is required. Not only this cable should comes under the underground, so that the any fire, any major fire incident also your fire water pump will be running. So those kind of the things plant people, process people, safety people know, but in our point of view also we have to keep in mind safety. I mean fire hydrant pipelines as possible we should take the pipelines to the underground. Then avoiding excessive changes in the elevation and the directions which cause the piping, and ensuring consistency in design, avoiding excessive amount of relocation and revisions by doing it right at the first time. It may not possible, but over the period of experience or we are doing mistakes, so we can learn from the mistakes and we can doing it right at the first time. So that's all from today's session, because we don't have any particular topic today. So these are all the piping roles and the responsibilities of a piping engineer. So any questions is there, we can go for question and answer sessions. We can start.
Thank you, Chandramohan sir, for this amazing session. Participants, you can post your questions. Sir will be addressing that.
Link.
This one only.
1 second. Could you please explain about the roles and responsibilities of a piping material engineer? That is what I explained. There is no separate piping material engineer. It is a part of a piping engineer whole, as a whole. Who's going to design the piping? He has to take care of the piping material design. That means piping material specification. That not only the piping engineer role, but it's also combined with the process. Because as a piping engineer, if any specialty, okay, I tell you one example. I have worked in a plant where that chemical is a specialty chemicals. I don't want to mention the name. That chemical will freeze. That freezing point of that chemical is 45 degrees Celsius. Another one chemical is 56 degrees Celsius. If the temperature comes down below the 50 degrees Celsius, that chemical will freeze, become solid, even it is inside the pipeline. So those kind of areas, the typical piping engineer may not know, even though if the detail engineering consultant, if you whoever detail engineering consultant, they may not know clearly about the specialty chemicals the owner is handling. So those areas we have to take guidance from the owner, and we have to design the piping. There we have to do the steam tracing is required or not, electrical tracing is required or not, if any jacketed pipeline. So what are the things you have to consider? So those, not only the piping, I mean piping engineer, so those kind of areas, process engineer involvement also is required. And then what will be delivered by the material engineer? What kind of interfaces he need to face? That's why I'm telling. Material engineer means what you meaning? I don't know. Piping, I mean piping engineer only. There will not be any material engineer, because if it comes to project, if it's a big project, there will be separate person will be there, but base is same. The mechanical is a base. So water interfaces he need to face means that fluid property only he is to needs to face. What kind of fluid they are using from start from the utility air, from water to a final product to raw material product. He has to deal with the process persons, how their phase is changing, temperature changing. Those areas he need to focus while designing the piping material. At the same time, he has to keep in mind about the cost, because wherever the stainless steel required, there may not be wherever the fluid contact is not there, that stainless steel it is not required. So there, if it is a big equipment, liner only required. Those kind of the things that piping material should keep in mind. What are all inputs piping material engineer needed from other disciplines? What are all the outputs from the material engineer? Same, we already explained. Could you please explain the job sequence during engineering phase? Which deliverable we prepared first, P&AD or layout or PMS? So first we will, layout is here considered as a two thing is there, a piping layout. Another one is a plot plan, plot layout we will call. So first thing we have to see the what process we are going to produce, that we have to clear. So based on the processing unit, first we need to think the location. So nearby you are going to buy a product from the existing firm, I mean existing company. There's so many kind of byproducts there will be there. Some of their byproduct will be the raw material for our new product. So we have to set up a plant close to the existing plant. You should not put far away from the plant. So the transportation cost and the pipeline cost, whatever it is, it cost will increase. So first we have to decide the plot plan where we are going to put. First we have to decide the what product we are going to produce and where you are going to set up the plant. And the second thing is P&AD. Obviously we know P&AD, if you decide the process, obviously P&AD will be there existing, because you are not going to prepare a new chemical, because already is there. Based on the demand, you are going to set up a new plant, any owner. Okay, he already having operating from another country. So other country he may exporting for the last 20 to 30 years. He may think, why we need to export, export cost and all high. Why don't we set up a new plant in other country where he is exporting already? So though he is having already have process design, P&AD, everything. So first thing is process, I mean product. Second thing is plot plan. Next is P&AD. Next is piping layout. Next is final one is the PMS. Before fabrication, before buying the material only, we need a PMS. Do we have access to codes online? Yes, but you have to pay API standard or Shell DEP standard. There is different types of codes available, standards available, but some basic things you can get from internet. But if in depth you want full detail, means you have to download. For the download, you need to pay for the particular website. Which deliverable will be freezed first, PMS or layout? Layout only, the first one. PMS will be the I mean here a layout means I mean about the plot plan, not piping layout. If it is piping layout, PMS is the first one. Next is the piping layout. A stress analysis will be done after all deliverables, or what stage a stress analysis will happen. Initial after the PFD, P&AD, next stage will be the piping layout. After that, fourth one will be the stress analysis. For any critical, I mean major pipelines, we need to do, if a high temperature, high pressure pipeline means we need to do a stress analysis. So that one is purely based on the owner and the stress analysis engineer. All deliverable operation will be carried out parallelly. Many deliverables are interlinked in this case. How will prepare a deliverable successfully on time? That is the project management. Because in a project we will depend upon the each and other disciplines. If you want to erect one equipment, the civil foundation should be ready. So we are depending upon the civil to install the piping. That equipment should be placed. Otherwise, you cannot fix the pipeline. So the equipment engineer has to fix, the commissioner has to install the equipment. So for one thing, I will explain here. For if you take a pump, first we will see the civil. First they will make the base foundation as per the drawing. After that, as per the FGL, FFL, as per the design, they will make the pump foundation with the packets. After that, we need to install the pump. Then we have to do the alignment, base frame alignment. Then we have to do the grouting. After that, we have to once again you have to check the pump center line with respect to the drawing. See, everything is clear. Then we have to install the piping. After installation of the piping only, we have instrument person can connect the instruments there. So those are all the interfaces. That is the project management. That is why every day each other disciplines will sit together morning and evening. They have to discuss and you have to implement the project. So after you erection the pump only, motor can be erected. After the motor erected only, you can connect the cable. So these are all interlinked. So that's why project management is very important. Could you please, is there any rule of thumb for piping engineering estimation, especially man hours and cost? There is no rule of thumb. By experience only you can came to know, because there will be a set of rule is there for doing 1 inch dia. I mean telling about the standard welding, not I mean telling about the proper welding. So those kind of, if you do 1 inch dia, 1 inch die means it may take 15 minutes to 20 minutes depend upon the welder, but it is for 6G welder they can do 15 to 20 minutes, he can do the 1 inch dia. So proper with the proper welding, that means if you do testing entity it will pass. So those kind of welding will take that much of time. So those kind of maneuvers only we can, by experience only we can came to know. Cost is, but before putting this one is they will, we came to know, yeah, there is not rule of thumb, I don't know. So some percentage is there, like a yearly we say 25 to 35% the piping, 60% will be the equipment cost. So some 30% will be the process civil cost. So those kind of things will come to the picture. Could you please explain about the how to prepare branch table for different line classes, at what basis it be selected? That's why we need a PMS, piping material specification. In the piping material specification, there will be a branch table will be there. For example, in a 20-inch line, you need to take for a half an inch line, which item you have to use, coupling or unequality or weldolate or sockolate, it all will be mentioned in the PMS. One table will be there. So if it is a steam line, what you have to, what fittings you have to use. If it is a cooling water line, what you have to use. Those kind of things, everything will be prepared in the PMS itself. That is called the branch table. That is what you are asking it in different line classes. Based on MOC, it will be differ. Based on the fluid handling, it will be differ. In the PMS is the Bible for the fabrication. PND is the Bible for the plant process, plant design. So these are all the two main things. Other things are supporting, isometric, piping layout. These are all to getting a picture only it is required. How to choose PT rating for different classes, or what basis it will be selected? PT means we're asking pressure transmitter. I would take a pressure transmitter. PT means, that means PT rating for different classes, at what basis it will be selected. Based on basis means MOC, fluid what it is handling, and what will be the maximum pressure it is going to handle that pipeline. So based on only PT. Could you please explain the material selection based on temperature? There is a separate table is there in API code. There will be a separate in ASME also it is there, mechanical engineers and ASTM. There is a separate table is there to select the material. It is a corrosive. If it is not like steam, obviously you have to go for a carbon steel, because compared to stainless steel, the carbon steel is here. Weldability will be high, and then cost is very less because there will not be any corrosive thing. If it is a steam means, so based on that some selection table is there that we can follow. Process will identify the pipe size, and MOC or piping engineer to calculate those things. That will be a purely process design. They is the one going to do the hydraulic study, and then the requirement of the pressure and the flow rate, everything. So process will design the pipeline sizes. MOC also will be combinedly we have to select the MOC of the pipeline according with the piping engineer. Is pipe seam software any good? Does it have limitation that you did not mention in the software lecture? So kind of software only, but we didn't use much here. So that's why I didn't mention that. I don't know much about pipe seam. Please explain the material selection philosophy for oxygen line. What are the things we consider for oxygen line engineering design materials layout? I don't have specific experience in oxygen line. If it is where which you are using, I don't know which factory, I mean which industry, what purpose you are using this oxygen line, I don't know. Air only you are mentioning oxygen, or I don't know. If it is air means GI line is more than enough MOC as per the material selection. For let's say for instrument air, service air, both is there in any plant. Service air means it is generally usable for cleaning purposes. So those kind of things, the utility air and the service air, those will be compressed by the compressor. And the part of the service air we take tapping to the instrument airs system. That means with the CMS, carbon molecular series, everything. From that we can get the instrument air. So those instrument air should not get we should not use a carbon steel pipe. We have to go for the GA pipelines, because if there is any rust formation is there, it will obstruct the instruments port. So we will go for the GA. So it will be according to the application. I don't see oxygen. If it is any air product you are working, means there will be a GA only, mostly preferable for air, because you cannot go for straight away stainless steel. It will cost you more. Could you please explain about the vendor design package? What are the things to be reviewed? Where to give important? Vendor design package means where we cannot design the our requirement. See, we are going to design one plant, so we know what will be the capacity of the plant. So the vendor we may not know. So based on that, our production is, let's say, 100 ton per day. So for that we have to build our final product storage tank. I'm going to produce 100 ton. Let's say I'm going to produce 100 ton mineral water. Okay, per day. So if there is no, I mean, there I need, obviously we need the storage space for that. If it is 100 times, at least we need 5 times higher the capacity we need. So we have to build a 500 ton capacity storage tanks. If it's a 2 or a single one, we have to decide. So those kind of the things comes under the design. That means owner. For to pump the mineral water from one place to another place, from storage tank to the tanker where you are doing the bottling. For example, I'm telling those pump you cannot design on your, because that will take it is unnecessary, it is waste, because already pump when vendor is there, they are doing the job from the so many years. So you have to tell the what pressure you need, what will be the available starting head, and how much flow rate you require. So based on that, they already have some sizing. Ready-made pumps are available close to your requirement. Some pump will be available, so they will supply the pump. Same like compressor, boiler, cooling tower, because everything we cannot design on our own. And we separate industries are there. So that is called vendor design package. We need to tell our requirement. My compressor has to give 6 bar, and I need 1200 Newton meter cube per hour. So based on that, they will close to your requirement, because exactly if you want, no, I want a 6.1 bar only output pressure, means they may not be available. There will be 6 bar available. You have to select that one. If it be 7 bar, you have to go for the 7 bar. So that is depend upon our requirement. Could you please explain about MR and TBE? I don't know what you mean tubular MR, material requisition you are asking. I don't know. Material requisition means this one, for any equipment we prepare the material requisition with the data, along with the process data sheet. We will mention the material requisition. For any pump, we will go for the material requisition. What is logistics, if any, green or brownfield project? Logistics means transportation, nothing but transportation. If it is a greenfield project, it will be far away from the existing. If it is a greenfield project, you are going to set up a new project in a remote place. Nearby, you won't get any utilities. You won't get any logistics. You have to transport your product or your raw material from far away from one place to your place. So those kind of things you have to keep in mind. Whether you're going to greenfield remote area, your logistics cost will go high. If it is a brownfield project, already infrastructure will be there, connected roads will be there. So your transportation cost will comes down. So that is what logistics. PMS will be ready before 30% model review. I think PMS should be get ready before that, before making any model. In my point of view, I involved in 2 or 3 projects. We did in that way only, because PMS basically, PMS is not every project. You no need to think, because if it is a cooling water, it will be a carbon steel line, ERW pipe, class C pipe. Oh, it is only. It will not be any. If you go for Europe also, they are not going to put in stainless steel. For any specialty chemicals only, you have to refer some other existing plant. You have to think about that. We have to discuss with the client. Our owner, everything we need to decide. PMS, mostly 90% of the utilities will be same. Even it is a refinery, or even if it is a petrochemical or is a power plant, everywhere air will be there, water will be there, steam will be there, oil will be there, diesel will be there. So those kind of PMS are already freezed long years back ago, already freezed. So then PMS will be easy only, but you have to cost wise you have to think according to the client, because some client will be very conscious about the safety and quality, so they will not compromise on that. Even though cooling water, I have seen one client, they want a seamless pipe in cooling, even for fire hydrant they want a seamless pipe and schedule 45. We suggest this one is not required, your cost will go triple the time if you go for single. They said okay, no problem, we want seamless pipe only, because they don't want any trouble in the future. But some client will say no, no, we will do the precautionary, we will not operate that much, we need only a ERW pipe only, weldable pipe only, schedule 10 pipe, it will be low cost. According to the client will be vary. Kindly guide regarding thermowell. Does the designing comes under the piping design? Briefly tell about it. No, no, I am telling about the thermowell means you have to consider while do the piping, because thermowell is in thermowell 80% of the thermowell, that unit will be inside the vessel. Outside only that transmitter only will be there. So while in future the instrument person going to remove, it has to come out. So the free space should be available above the thermowell. I mean, it's any pressure transmitter or temperature transmitter. So you cannot put the pipeline on the top of the thermowell, so that in future the instrument person cannot remove. So those kind of the things you have to keep in mind while doing the piping design or piping layout. That is what I want to tell. You have to basic things. I mean, how the thermowell it will be, you should know. No, no, it is instrument part, it is not my part. We cannot tell like that, because in future if any is there, we only going to do the modification for the piping. So the time cost and all will go high. Could you please explain interdisciplinary checks of piping with civil, mechanical, electrical, instrumentation and telecommunication? That factory to factory it will get differ. Piping with the civil means our support, our interface with the civil is mainly with the support for the piping. If it is a pipe rack, no issue. But if it is a low level piping, we need their help in that the concrete sleeper, concrete supports, because in project now first they will want to wind up the civil. If it is a FGL, we will call a FGL, floor finished ground level, finished floor level, like that. So they will put everything, acid proof tiles, everything they will clean, mirror finish they will do. After that you want to place one pipe, you have to again you have to rework on the floor. So those kind of the things we have already, we have to keep in mind. So those area you have to tell in civil, you know, this area you don't do the finishing work, in future we may require a support here. So accordingly we have to interface with the discuss with the civil people. Mechanical is yes, because whenever mechanical means we have to connect our piping to the any rotary equipment or static equipment, because it's rotary equipment they will do all alignment with respect to the base frame, with respect to the motor, everything. If you are piping, after that if you are connecting any piping, if you are tightening with the nozzle, your rotary equipment may get disturbed, alignment may get disturbed. So you have to keep in mind that piping all should complete. Before that you should not do the alignment, the mechanical person should not do the alignment. After connecting the piping with the rotary equipment, then the pump has to be fixed according to the piping. After that only motor has to be aligned according to the pump. Those interface you have to deal with the mechanical. So that is what this kind of electrical same. That cable you should not connect with the motor, because while do all the alignment, if the cable you want to connect, if the cable tension will be more, the alignment may get disturbed. So after the cable connection only you have to do the alignment. So those kind of the things, it will be differ from place to place. I am talking about the pump, same like for any static equipment, same like for electric other disciplines. That case to case, person to person, factory to factory will vary. Please explain about feed package, basic engineering feed package. That is called a front end engineering and design you are telling. That will take a lot of time. That is what in the whole training session we have discussed about that one. Does piping material is mandatory for 3D model reviews? Not necessary. There is no specific piping material engineer. If it is a big project, they will initially only their support is your support is required on that. But mostly piping engine will take care of the piping material specification. Okay, you are not going to discover any new thing. Whatever already is there, you are going to implementation only. How to identify the change in process fluids, in which drawing it is clearly mentioned. PFD will refer after freezing PNAD. No, PFD is the first one. It is the base. After that, from the PFD only, we have to develop the PNAD. PFD will shows the which from which equipment the fluid is going step by step. In PFD, PNAD will be mentioned the what are all the valves, what are all the instrument items, what are all the controlling measures, what are all the tagging philosophy, that and all comes under the PNAD. But a process fluid nature you will come to know about at the end of the PFD itself. Who will be responsible for the material selection diagram? What is the difference between PFD and the material selection diagram? Both are entirely different. Process flow diagram is completely comes under the process engineer, where they know clearly, they know about the which one is the raw material, where it is getting the process, and where it is getting as the final product, where we are getting the final product. That all comes under the PFD. It is purely based on the PFD. In PFD, we will not mention any MOC, anything. Only the equipment only we will mention. If it is a column, we will mention as a column. If it is a pump, it will mention as a pump only. Even what type of pump also we will not mention in the PFD. In PN only, we will elaborately we will mention what kind of column, how many trays will be there, what will be the exchanger type, what will be the pump type. Those all comes under the PNAD. Material selection diagram will be entirely different. That will be depends upon the what fluid you are going to handle, what fluid you are going to produce. At what stage piping material engineer's role will start? At the end of the PFD itself, process, once we fix the process, our piping material engineer works will get start. Because once the product freeze means any plant, even take any owner in the world, first based on the first we need why we need these kind of things. First we need money. To make money, what plant you have to proceed, whatever the demand is there, then only to according to the demand only you are going to set up a plant. Already if in the same region already 3 or more manufacturing plant is there, there will be enough supply is there, we are not going to put any new plant. Where will be the demand, where will be the specialty product will be there, that plant only we are going to set up. If you are going to set up, definitely you need the basic process design. That also you are going to get from the process design person who did the process design for that plant. Obviously, will get design from the same plant only. Okay, what are all the equipment they use there? The same equipment only you are going to put here. Only the capacity only going to differ, and any that process, if you have any improvement they have done in the equipment or there in process or controlling philosophy, that only you are going to implement. So there is no new thing, there is no new product we are going to design. Already is there. Based on the demand, we are increasing the number of factories, number of industries. That is what. 90% of companies are hiring special persons for my piping material engineering based on experience only, not special persons. But he has any experience in piping, piping material engineering, so they are hiring that one. What is dead leg in piping? Dead leg in piping means the name itself it is mentioned. Where will be the end point? That will be the dead leg. Say some tapping you are taking. When you say header is there is 5 tapping you are taking. At the end of there will be some space will be there. That is the dead leg. There will not be any fluid circulation. So once the fluid got filled means that material, that fluid will not get replaced. If it is even though circulated, because pressure is even inside the pipeline. So that area we call as a dead leg. So those area dead leg only we may expect the more corrosive. We may expect because stagnation will be there. So that's why we normally, if you know, if you go enter any plant, your cooling water header, raw water header and all will not leaking much, but your fire water header will be leaking much because fire water we are not circulating frequently. Okay, there will be some stagnation. If any pressure loss is there, that time only a pump will getting start, jockey pump. Whereas in cooling water, raw water, that free, every circulation is there. So there will not be any stagnant. So the leaking also will be corrosive also very less. So that is called a dead leg. Where there is no flow, no circulation is happening, that is called a dead leg. What is FGL and FFL? FFL, yeah, FLL, I don't know. Here different name is there. Every project they're mentioning. FGL means finished ground level, as far as I know. FFL we call finished floor level, and then NGL is there, natural ground level, and then GL is a ground level like that. FLL means I don't know. It differ region to region. It is getting different. If it is Europe, they are mentioning different. Here Southeast, they are mentioning is different. That is area to area. It is different. Branch table will be there in PMS. Yes, of course, it will be there. But my question is to how to prepare a branch table. That will be standard is there. Branch table, there will be separate standard spec is there. Obviously we know already we explained about the piping component. No? So where we can heat that will be go in depth. HSA that are not weldable. If you do welding, what will be the nearby the equipment that composition of the material will get changed. So those kind of thing comes into the picture. So there will be separate table will be available. So in what size, up to what size you can take, use what kind of fittings, what kind of branching you can take according to the specific pressure and temperature, according to the specific fluid. PT rating means pressure temperature rating. Yeah, I already explained. I thought it's a pressure transmitter. Okay, right. Pressure transmitter temperature rating is already we have seen in piping components, right? If it is a flanges, there will be a standard flanges there, 150 pound rating. Same like that for any component, not only flanges, same like equality, everything, there will be a thickness is there. If it is a flange rating is there. So if it is a 150 pound rating, there will be in ANSI B 16.5, there will be a table is there. APS standards will be there. So according to the, if particular temperature, it will withstand this much pressure. If the temperature increases, the pressure withstanding capability will comes down. So accordingly, you have to choose for let's say, what is a super saturated steam for 10 bar, you have to go for 300 pound rating. For the same pressure, if it is a cooling water means you can go for 150 pound rating. So accordingly, pressure temperature, that the rating will be, choosing the component will be differ. That separate table it will be available. Oxygen is oxygen, not air. That is what I'm telling. I don't have specific experience in oxygen. That will be specialty. Like I'm telling now, that will be specific. In many of the plant, we are not handling oxygen. It will be mostly they mostly used in like air products, like bottling unit, like where hospitals they are using or some other any special purpose they are using. Now those kind of areas only they will use this oxygen. Mostly in oxygen, GA is more than enough. It's up to me because I have used the instrument here. So MR material requisition will be prepared by whom or who will approve what is the use of material requisition. Material requisition will be prepared from by the mechanical engineer only. For any equipment, we have to prepare the material requisition. TB is a technical bid. Okay, right. Technical bid evaluation. What are the things needed to consider for valve and special items procurement? Technical bid evaluation is nothing. First, we need to fix our requirement. What we need. Okay, first then we have to compare the apple to apple comparison only. You have to do. Technical bid means that is a requirement. Where question is very clear. Now you already know about the evaluation. Taking how to do technical bid evaluation. You have to get a minimum 3 quotation from the vendor. First, we have to see about fulfill our requirement or not. MOC like pressure rating, temperature rating, everything, and then you have to see about the cost. That will be under the commercial things. Cost and delivery period that all comes under the commercial. What are the things need to consider for valve and special item? Special items procurement. Our requirement already in valve training session we have seen that one. What is our requirement only we need. If the lowest cost is the lowest ball valve will be the lowest, we cannot go for ball valve, we cannot go for the needle valve. What is our requirement, where we are going to utilize the valve? So from that process itself, we will freeze the what kind of valve it is. Only thing is, technical bid evaluation means some vendor will give the compatible material. They will tell, sir, this material will also withstand your required temperature and pressure. This material also will temper. So based on that, we have our own material acquisition. So we have to match with that the material MR. Kindly share potential project funding sources from your experience and funding requirements were put into consideration. It was not clear, that one. Funding experience. Who prepares the material selection diagram? Piping materials. What are the details? Already we have discussed about this question. How to identify the design pressure? V61 was there are one settings from how to find. I'm also not clear about that. Okay, I think, is there any special consideration or variable in stress analysis for different services? Yes, it is there. I hope you attended the stress analysis. It will go in depth. So we cannot see in depth, I mean, detailed again here. Variable in stress analysis means not clear about the question, because it is critical line to line, will be service to service, it will get varies. Okay, is there anything? Anu, is there
Any more questions, anyone? You can unmute and ask if you have more questions.
So I have a question. Can you explain the importance of schedule number in while designing a pipe, and what are the factors that should be considered while designing pipes for various industries?
you are asking schedule?
Yeah. What are the importance of schedule number while designing pipe?
So main thing is pressure only. See, there will be a pipe rating is there. If you go for any pipe chart, okay, there will be while preparing PMS itself, how much pressure it will withstand. So based on that, we have to select the schedule, because schedule is nothing but it is clearly mentioned about the thickness of the pipe. For SS pipe, if it is schedule 10 means, that will be different thickness. For a carbon steel pipe, if it is schedule 40 means, there will be thickness of the pipe. For low bore pipe, there will be thickness will be different for the same schedule, and the same schedule for the large bore pipeline, there will be thickness will be different. So based on the pressure what we are going to handling, so based on that only the schedule will be different. So it's nothing but we have to choose the thickness accordingly to our pipeline size and the pressure that we're going to handle.
Okay, sir, and it comes under which standards, like ASTM or API?
That one ASME standard and ASTM.
Okay, sir, thank you.
Any more questions? I think we have no more questions. So this was our last training session. So thank you, everyone. iFluids would like to express our gratitude to all of you for being a part of this training program, and also making this journey truly rewarding for all of us. Thank you. And as we informed in the group, you'll be having the reassessment scheduled from August 24th, the coming Thursday, to August 31st. From 6 to 7 p.m. So whoever has failed on assessments, you will have to take the reassessment. Only then you will be receiving the certificates. So the link for the reassessment exam will be given on a daily basis to whoever has failed on specific topics. So your attendance link has been shared. Please mark your attendance. And We would also like to highlight that participants who have demonstrated outstanding performance in the assessments with utmost genuinity, along with consistent attendance and active engagement throughout the training sessions, will be shortlisted for interview with iFluence Engineering. The HR team will be contacting you directly through mail. So please keep a check on that as well. So thank you, everyone. You'll be having the assessment of this module tomorrow from 11 to 11:30 a.m. IST, and your reassessment will start from day after tomorrow. So thank you, everyone. Thank you, Chandramohan sir, for taking this session, and thank you, everyone, for joining and asking questions. This was really a great journey. Thank you so much. I think we can wind the class. Thank you, everyone.